This is a series of lecture on pharmaceutical dosage form. In this lecture we will discuss about excipient, and particularly in excipient we will discuss about filler which are used in pharmaceutical dosage form. So first of all, a definition of excipients. Excipients are also called pharmaceutical adjuncts or necessities or non-therapeutic agents. These agents give a unique characteristic composition and physical appearance to a formulation. There are two aspects in which excipient play their role. First aspect is the manufacturing and second aspect is the patient. Now excipient play an important role in manufacturing process, and from manufacturing point of view excipient play an important role by disintegrating the drug into small particles to reach the bloodstream more quickly, and there are other excipients which increase the stability so the dosage form will have maximum effectiveness. The excipient also play an important role in drug identification. Some excipient also make a product taste better and look better. They also help a drug to reach the site of action. These points are from the patient points of view. The better taste and better look are the advantages of excipient from the patient point of view. These factors are important, so they improve patient compliance, especially in children. Although technically inactive from a therapeutic sense, pharmaceutical excipients are critical and essential components of a modern drug product. In many products, excipients make up the bulk of the total dosage form, significantly affect the chemical and physical properties of the final dosage form and thus the biopharmaceutical profile. So these are the excipient. Pharmaceutical excipients are substances other than the pharmacologically active drug or pro-drugs. General function of excipients. We must know about the general function of excipient. What are the general function of an excipient? First of all, they help transporting the drug or the active drug to the site of action. For example, this was an active drug. They are going to transport this drug to the site of action within the body. For example, this was paracetamol. It will reach to the site of action within the body to decrease the pain. So excipient also play an important role in the manufacturing process as discussed earlier. For example, this is a manufacturing process of tablet manufacturing. This was the active drug. It is mixed with excipient, and then wet massing process. This is the wet massing process. The wet mass is granulated. This is the granulator, and these granules are then compressed into the tablet dosage form. So these were the excipients which were helping us to convert powder into a tablet dosage form. There are some dosage active pharmaceutical ingredients. If we take them as such, for example, diclofenac sodium, they will irritate our gastric mucosa and will cause stomach problem. But if they are presented as a anti-recorded tablet, now the stomach is not affected by them. The excipient also help the dosage form to disintegrate into smaller particles enough to reach to the bloodstream. Excipients simply make a product taste better and look better. It is said by someone. They also improve patient compliance in especially in children, by giving dosage form, a good or better test. Excipient make up the bulk of total dosage form. They are helpful in producing proper shape of a dosage form and to deliver drug to receptor in the body where they act. Now, list of most commonly used excipients in a dosage form. They include diluents or fillers, binders, viscosity builders or thickening agents, surfactants or wetting agents, disintegrants, lubricants and glidants, preservatives, solvents, flavoring agents, buffers and tonicity adjustment agents. First of all, we will discuss about diluents. Diluents are also called fillers. They are used in tablet formulation, usually significantly affect the chemical and physical properties of the final tablet, thus affecting the biopharmaceutical profile. However, they are also used in capsule dosage form. Classical examples of this are calcium salt, which can be utilized as filler, which interfere with the absorption of tetracycline from the gastrointestinal tract. So these were excipients. They were affecting the bioavailability of the tetracycline. So the excipient, although they are considered as inert, but they also affect physicochemically, so they care must be taken in their selection processes. For example, calcium diabasic and phosphate and tetracycline. So physicochemical changes caused by diluent. They also might render the product unstable and might cause problem in manufacturing process. Tablets are designed so that the smallest tablet size, which can be conveniently compressed as a form, but there are some active pharmaceutical ingredient, for example bisoprolol, the dose of which is 2.5 mg, so it cannot be compressed. So diluents or filler are added to make a bulk up to 120 mg or 130 or 170 mg, so that a tablet can be easily compressed. So here we use or add diluents or filler to make the bulk. Most commonly used diluents or fillers include, we will first name all these and then we will discuss each in a detail. Cellulose powder is the most commonly used filler in a tablet in capsule dosage form. Microcrystalline cellulose 101, 102, 200 and 112 grade. Lactose monohydrate 100, 200, 300 and anhydrous spread grades. These grades are according to the particle size. 100, 101 and 100 are the smallest, while 200 and 300 are the largest mesh sizes of these fillers. Starch and then pre-gelatinized starch 1500 grade. Starch sterilizable maize, calcium carbonate and then calcium silicate, cellulose silicified microcrystalline, which also contain aerosol or colloidal silicon dioxide. Then is the erythritol, and next one is the calcium hydrogen phosphate dihydrate. Next one is the dibasic calcium phosphate. Next excipient is the calcium phosphate tribasic, calcium sulfate, calcium lactate, These are all calcium salts: calcium carbonate, magnesium carbonate, magnesium oxide, sucrose, sugar or sucrose, sugar compressible, which is in direct compression, sodium chloride, ammonium alginate, dextrates, dextrine, dextrose, liptitol, minitol is maltitol, minitol is mainly used in chewable tablets in a direct. It is a directly compressible material. Then is the lactose inhalation, talcum. Here are some fixed combinations which are provided by the manufacturer. For example, lactose monohydrate and cornstarch. Then lactose and monohydrate and powdered cellulose. Next combination is the lactose monohydrate and povidone, lactose monohydrate and microcrystalline cellulose. And so we will first discuss about the cellulose powder. Brand name is Elsima. Powdered cellulose is used as a tablet diluent in filler and 2-piece hard capsule. In both contexts, it can act as bulking agent to increase physical size of the dosage form. For formulation containing a small amount of active ingredient, it is also used in tablet formulation as a filler. This is a powdered cellulose container, small size container. However, it is also available in bags and large size. This is the powder of cellulose powder. Next one is the cellulose microcrystalline, most widely used filler in a tablet and capsule dosage form. Mostly the tablet dosage form and rarely in capsule dosage form. 101, 102, 200 and 112 grades. Most commonly used brand is Avicel and another one is the Compricel. Microcrystalline cellulose is widely used in pharmaceuticals, primarily as a binder or diluent in oral tablet and capsule formulation, where it is used in both wet granulation and direct compression processes. In addition to its use as a binder or diluent, microcrystalline cellulose also has some lubricant and disintegrant or secondary disintegrant properties that make it useful in tableting processes. Microcrystalline cellulose is also used in cosmetics and food products. Particle size increases as number increases. That is 200 is the largest and 101 is the smallest particle size. 101 grade is mainly used in wet granulation formulation of tablets. 102 grade is used in direct compression formulation of tablets. 200 grade is also used in direct compression of tablets, but size is larger as compared to 102 grade. And next one is the 112 grade, the low moisture content grade of cellulose. It is the low moisture grade and is used in formulation of moisture sensitive active pharmaceutical ingredient like ranitidine hydrochloride tablets. This 112 grade is used as a filler or a diluent. This is the microcrystalline cellulose bag and this is the microcrystalline cellulose powder which is used in tableting process. The next one is the cellulose silicified microcrystalline or ProSol. It is a combination of microcrystalline cellulose plus silicon dioxide or aerosol. It is mainly used in tablet and capsule as a diluent. It is silicified, that is silicon dioxide is added. Microcrystalline cellulose was specifically developed to address the loss of compaction that occur with microcrystalline cellulose after wet granulation processes. There may occur some loss of compaction or compression may not be easier, so silicon dioxide is added, which aids the compression process and hence improved compaction in both wet granulation and dry compression. This is the colloidal silicon dioxide and microcrystalline cellulose. This is the cardboard drum, and this is the powder, and these are the tablets and capsules, which are actually the final dosage form. Now next one is the lactose monohydrate, which is obtained from milk 100 to 200 and 300 grade. As we discussed earlier, that these grades are according to the mesh size or particle size of lactose monohydrate. Pharmatose and Supertab are the most commonly used brands of lactose monohydrate. Lactose is widely used as a filler and diluent in tablets and capsule dosage form. Lactose is also used as a diluent in dry powder inhalation. For example, the particle size range from 100, 200 and 300. So how we can select a range of this lactose for our formulation? This is selected according to the capsule size. For smaller capsule size, the smaller range is selected, while for larger capsule size, for smaller capsule size, fine grade of lactose are used, while for larger capsule size, coarser grade are used. And similarly, for wet granulation process, the smaller mesh size lactose is used, while for direct compression process, the larger particle size of lactose are used. And is described here, fine grade of lactose are for tablet formulated by wet granulation, while coarser grade are agglomerated monohydrate and anhydrous or spray-dried lactose are for tablet formulated by direct compression. About starch and pre-gelatinized starch as a diluent or filler. Starch is a versatile excipient used primarily in oral solid dosage form or oral solid dosage formulation, where it is usually utilized as a binder, diluent, and disintegrant. Cornstarch and pre-gelatinized starch are used as tablet and capsule diluent and filler. In comparison to starch, partially pre-gelatinized starch may be produced with enhanced flow and compression characteristics, such that the pre-gelatinized material may be used as a tablet binder in dry compression or direct compression process. Starch is one of the most commonly used tablet disintegrant at a concentration of 3 to 25% weight, and weight typical concentration is 15%. We will discuss this. What does this mean? The 3 to 25% weight and weight mean, for example, if you use 10% and a single tablet weight is 100 milligram, so 10% of 100 milligram will be 10 milligram. So in this tablet formulation, the weight of single tablet, if it is 100 milligram, so we will use 10 milligram of maize starch. But the optimum or typical concentration of tablet of starch in a tablet is disintegrant is 15%. So we must use up to 15%. of starch in a tablet if we use it as a disintegrant. 15% also mean if a tablet weight, a single tablet weight is 300 milligram for example, and we use 15% starch, so how much starch we need to be added? 15 multiplied by 300 divided by 100, so it will be 45 milligram of maize starch. If tablet formulation is freshly prepared, starch paste is used at a concentration of, and tablet formulation freshly prepared starch paste is used at a concentration of 3 to 25% weight in weight as a tablet binder. Starch is used in a dry form as a disintegrate and as a paste form as a binder. This percentage also mean 5 to 10% as a the optimum range in which it is used. This also mean 20% mean if total weight is 300 milligram of single tablet, then 20 milligram, then 20% weight in weight mean 20 multiplied by 300 divided by 100, so 60 milligram of this starch paste will be added to our tablet formulation for binder properties. This is a maize starch bag, and this is the maize starch powder. This is the paste preparation process. First of all, it is taken in a kettle or in a container, and then it is mixed with a warm water, slightly warm water, and then it is either heated on a stove to form this paste. The slurry is first prepared, and then the paste is prepared by heating it on some heating source, for example water bath, or by adding boiling water to this slurry to convert it into this paste form. Now next one is the calcium phosphate, dibasic, tribasic, monobasic, anhydrous, dihydrate, trihydrate. All these are calcium salts which are used as fillers. Calcium anhydrous dibasic calcium phosphate is used both as filler and as a source of calcium and nutritional supplements. It is also used in pharmaceutical products because of its compaction properties and the good flow properties of the coarse grade material. 2 particle size grades of anhydrous dibasic calcium phosphate are available, which are used in pharmaceutical processes, pharmaceutical industry. First one is the milled material, which is typically used in wet granulation or granulated or roller compacted formulation. The unmilled or coarse granulated material is typically used in direct compression formulation because the particle size in this case is larger. Dehydrated form has more compaction and lesser problem like friability, capping, and lamination is observed with hydrated calcium phosphate. The dehydrated form as compared to the anhydrous form has more compaction and lesser problem like friability, capping, and lamination as are observed with the monohydrate form. In dehydrated form, there will be more compaction and lesser problem of friability, capping, and lamination. This is the calcium phosphate dihydrate or anhydrous bag, and this is the material. Next one is the mannitol. Mannitol is also pharmaceutically active and used in injectable form as a osmotic diuretic, but in oral pharmaceutical solid dosage form it is mostly used in chewable tablet as a filler in direct compression process. So mannitol is widely used in pharmaceutical formulation and food products. In pharmaceutical preparation, it is primarily used as a diluent. 10 to 90% weight of tablet formulation may be mannitol. So where it is of particular value, since it is not hygroscopic and may thus be used with moisture sensitive products. Moisture sensitive active pharmaceutical ingredients. Mannitol may be used in direct compression process as such because it has good compaction properties, for which the granular and spray dried mannitol are available. Or in wet granulation process it may be used. Granulation containing mannitol have the advantage of being dried easily since it is not hygroscopic. Specific tablets for application include antacid preparation, glyceryl trinitrate tablets, and vitamin preparation, and also mannitol is commonly used as an excipient in the manufacturing of chewable tablets formulation because of its negative heat of solution, sweetness, and mouth feel is given by mannitol. For example, Montelukast tablet, they are prepared by this direct compression process in which mannitol is used as a diluent or filler and gives sweetness and a cool mouth feel because of this negative heat of solution. This is mannitol powder. Now the combinations of fillers, this makes the formulation pharmacist an easiest formulation. First one is the lactose monohydrate and microcrystalline cellulose, brand name is Microcilate 100. Microcilate 100 is used as tablet and capsule diluent. Lactose monohydrate and microcrystalline cellulose can be used in tablet for direct compression process. It contains 75% of lactose and 25% of microcrystalline cellulose. Next one is the lactose monohydrate and povidone K25 or K30 tablet and capsule. This is a tablet and capsule diluent containing 96.5% of lactose and remaining portion is povidone K30. It is 0.5% and lactose monohydrate is 3%. It can be used to formulate chewable tablets, lozenges, effervescent tablet, and controlled release tablets by direct compression process. It is suitable for low dose drugs. And this lecture is continued. Thanks for watching. Stay tuned for more lecture.